Hello everybody, my name is Vaughn, and I'm going to be going over some C++ with CRYENGINE. And today we're going to start our first tutorial, and we're going to be covering the basics. So we're going to get our project set up. Once we get our project set up, we're going to create two new files, and then once we create two new files, we're just going to jump in and create our first component. So this is basically going over C++ with CRYENGINE and just building our first component system. Now for the game that we're going to be making, we're not going to be making nothing too complex per se. We're definitely going to try something different than other tutorials I've seen. We're going to actually use the isometric pathfinding C++ template, and then from there we're going to build a clone pretty much of XCOM. It's one of my favorite games, and I feel like we can cover a lot of basics, game logic, stuff like that, basic game loop. By doing this type of game, basically. So first things first is make sure you have 5.6.5 installed, which that's one I have installed already, and I'm already at the portion where I just create my project. Also, make sure you have Visual Studios installed, either 2017 or 2019, or whatever the newest one might be. I'm not going to dive in too much setting that up. You should probably read the tutorial setting up CRYENGINE with with Visual Studios. It's pretty straightforward. When you install Visual Studios, you just want to make sure you install C++. When you install Visual Studios, it's like packages it goes with. So first things first, we're going to create our project. Like I said, we're going to pick isometric. I already had the path I wanted to go to, and I'm just going to call our project like I said, we're making an XCOM clone, and this is for tutorial and educational purposes. So the creators of XCOM, please don't be upset that we're using the name. So like I said, this is just for tutorial purposes. This is not going to be sold, sell, to resell. This is just for learning and developing, and learn how to develop. So I figured we'll just name ours just XCOM. I think it's like XCOM like that. No, we can do all lowercase. That's fine. So just XCOM is fine, and then just go ahead and say create project. Once you create project, just make sure you let the editor boot up first. We are going to load into the example map, and the reasons why is because there's some metadata it needs to like produce, and then once you do it once, it makes it going back and forth going a lot quicker. So we're just going to go to open levels example, and we're just going to let the example load up. Whenever it feels like loading up. So like I said, yeah, doing this the first time. Alright, so as you notice, this is a basic level. We have this navigation area here. We have a red dot, which is kind of showing where our cursor would be. It's kind of out of a line because we're in the editor. But that's fine. We have a spawn point and some boxes, just the basic example level. And we can just hit save, and now we can just immediately close that out. With that closed, let's go ahead and head over to our CRYENGINE, and we're just going to go to our project right here, and we're going to say reveal file explorer. And once we do that, there's a few things we want to do. The first thing is we have this game.cry project. We're just going to rename this game cry project to XCOM. Just hit enter. Make sure it says XCOM.cry project. Don't change the .cry project, just everything before. Second thing we're going to do is open this up in Notepad++. And what we're going to do here is look for this right here. Line number 18, where it says bin 164 game DLL. We're going to say XCOM DLL for that. Save. And then that's it. Once we save that, we can close this out. Now we can go into bin 164, delete game DLL. We don't need that anymore. Let me get back to the main directory. Inside the main directory, we're going to go to code, and then we're going to go to components. And this is just for me. We're going to set up our component systems now, or just rearrange this to make it look better in Visual Studios. So we're going to create a new folder, call this player, And we're going to grab both the player H, player CPP file, and just move it into there. I'm going to create another folder for spawn point. And same thing, we're just going to move spawn point into there. And for bullets, what we're going to do actually for this one, we're going to create a new folder, and we're going to call this weapons. And we're just going to drag bullet right into weapons. So now we have this kind of organized for ourselves. We're now going to go into player, and in here we're just going to create a new folder, and we're going to call this status. Within status, we're going to create, so within this folder, we're going to create two new files. And this, I do it this way. It seems tedious, and there's an easier way to do it, but honestly, I just do it this way. It's easier for me not to mess up something, or I can more control over it. But we're just going to create a new text document. So new text document, and we're just going to rename the entire text document, and we're going to name this our status component, capital S, capital C, and then .cpp, and then you're going to hit enter. You're going to get this are you sure? Just hit yes, doesn't matter. And then now we're going to create another new text document for our header file. Make sure we name it the exact same name as our CPP, so status component .h. So we have status component.cpp, status component.h. And then we're going to back out to weapons. And in here, we're going to say new. Actually, we're not going to create anything new here, but we are going to create a new text document. We're going to delete all this. We're going to say weapon base component .cpp. And then we're going to create another one for .h. So weapon base component .h. So once we have that done, we can go back to the main directory now. And inside our main directory, we're just going to right click on the Cry project and generate solution. Generate. Give it a second. And done. So once that's done, now we have this folder called solutions. We're going to go in solutions, Win64, and scroll all the way to the bottom, and you're going to see the .sln. If you don't see the .sln, just make sure you go to view and just check file name extensions. Make sure that's checked, and then you'll be able to see all the extension names. So with xcom.sln, we're just going to double click on that, and it's going to open up your Visual Studios. Once that's done, what we're going to do now is make sure that we go from debug to profile. And I'll explain more as we continue on, but for right now, profile works perfectly for what we're doing. Like 95% or probably even 99% of the time, you're going to be building a profile. Never really in debug unless you're really diving into debugging something. Profile still is like it's like a mix between release and debug. You get the fast compiling of release in a sense, but you also get the benefits of debugging, but not like in depth. But so profile just works. So with that, we're going to go straight to our solution, and we're just going to click on it. We're not going to change anything from here. We're just going to just click on our solution, click on the arrow to the left of it, and now we can see our entire solution. What's inside our solution? We have a CMake list, we have our standard AFX, we have our game plugin.h and CPP, and we have our components. This is a folder, and then we have our three other folders right in here. There's a few things we need to update because we changed some things around. First things first, let's go to game plugin.cpp, and in here you're going to see this line number 4. It's going to become red, and it's because it's looking for player.h and doesn't know where it's at. So if we just go highlight the entire player.h, hit backspace one more time, and then do /, now we get these options, player, spawn point, weapons, and just hit down arrow until you see that blue highlight, and then enter, down arrow again, enter, and that fixes that problem. So we can save. Don't worry, the risk of the line will go away. Now we're just going to jump into player.cpp and fix the next issue. Line 3 and 4 is going to call, it can't find it because we rearranged that. So let's go ahead and highlight, start with bullet. So we're going to highlight all of bullet.h and just type components / and down arrow, highlight over weapon, and enter, highlight over bullets, done. And then we'll do the same thing for spawn point. So components / spawn point, down arrow, spawn point. That easy. And if we hit save now, and then now we go to build, so we went build XCOM. So in that build solution, just straight build what we're working in, which is the XCOM solution, and we should get succeed. Yep, succeed. So it built our DLL, you see that? Now it's called XCOM DLL, and it's located in the bin folder, and all is good. So next thing we're going to do, let me just zoom out a little bit, is we're going to just jump into our status component. So our status component is going to be taking care of everything status-wise, right? So this is probably become a pretty big header file, but we're going to start small and simple and then build upwards, because we can kind of copy and paste certain code to work. Like for instance, health will probably work the same as stamina, or probably work the same as this. So it'd be like kind of doing the same thing again, just calling it something different. And you'll see what I'm talking about. So first things first, the first line of our header file, we're just gonna make sure I click. So I'm actually actively typing in here. We're gonna do the hashtag symbol or shift 3 and just pragma once. Again, I'm not going to go into too much detail of why this is necessary. Just understand pragma once. You're good to go. And then we're going to do another shift 3, which is the hashtag, and include. And this time we're not going to use quotes. We're actually going to use left and right arrow, or just shift left arrow, and automatically it'll make the right arrow. And that applies to anything really in C++. If you just do the left arrow or left bracket or left curly bracket first, it would always automatically put the right side for you. So you don't have to worry about doing left and right. It'll just, once you do left, it'll do right automatically. So we're going to include the entity interface. So to do that, we just type CRYENGINE for entity system. Again, it's already highlighted, so I can just hit enter. It already gives me the / and now I just need to look for what header file I need, and I need IE entity, not entity.h, but entity component. Save. The next thing we're going to do is include. We're going to include another thing from the CRYENGINE. So we're going to include the schematic. So cry schematic, not 2, but just schematic. And then core API. So I just typed in core, and then once it find out I'm looking for API, I just hit enter, and then automatically did it for me. And you'll see why we did that in a few. So now we have schematic core API in, and we have our iEntity component interface. And to know that if it's an interface or not, we see this I here. It's kind of like a standard that most programmers should be utilizing. Is if you're making a class, C. If you're making a strut, S. If you're making an enum, E. And we put those letters in the beginning of what we're making, so we understand that this is a class, this is a strut, or this is a enum, or this is a interface. That's just a principle that you should follow. You should always do, and I'll show you why. So our class is going to be status component. So we're going to say class C for class status component. Now again, we can just name this status component, but what if down the road someone else is using your code and they're trying to figure out what is status component. Is it a class? Is it an interface, like a strut interface? Is it just a strut? Is it just an enum? Like, they will never know until they actually have to look into what status component is. If you just put C in front of it, they automatically know it's a class. And it just makes things easier. Again, it's just simple etiquette and principle that you should be doing in C++. So with that, we're just do colon public, because now we're going to inherit, and what we're going to inherit is the iEntity component. So iEntity component, and again, it finds out what I want, so I can just hit down arrow. Once it's highlighted, hit enter, done. Enter again, and then left curly bracket automatically does the right side with the semicolon, and then now I'm just going to hit enter, enter, enter. So for status component, we're going to do a few things. So we're going to dive into exposing some elements into the editor so we can have some more, so we can tweak what status component does based on what it's attached to, right? We can hard code it, but it's actually a lot easier if you just expose some elements to the editor. That way you don't have to keep rebuilding the solution over and over again if you just make some minor edits, and you'll see why. So the first thing we're going to do is create a strut, and strut, again, STRUCT, and it kind of just automatically knows, hey, there's a code snippet for strut. And you can do a lot of code snippets. You can actually make your own, but I won't go into that so far. Just letting you know that that's a possibility you can do. So for strut, we're just going to name this S, right? And we're going to call this status. And that's it, just S status. And then enter, curly brackets again. So left curly bracket, enter. So what's going to be inside of our strut here? Inside our strut, we're just going to have some basic parameters for the actual status component. So one of the basic ones we're going to use is we're actually going to utilize the schematic. This is why we add schematic core. It's a lot easier just to add the core API. You get exposed to the namespace with all its abilities, with all its, I think, classes and struts it has inside its namespace. For instance, like range. So you'll see. So we can do schematic, and then automatically it knows that you're looking for schematic namespace. We're not looking for 2. We're just looking for schematic regularly. And then colon range. Range. And you'll see right now it gives you a hint. And this hint says, hey, you need a minimum, maximum, a soft maximum, soft minimum, soft maximum, and then you need a class type, or t-type equals float. So that just tells you that you just have to do this. We're going to say 0 for the minimum, and then for the maximum, let's say 1000. Right? And then comma again, 0, comma 1000. Now we have 0, 1000, 0, 1000, comma, and now we just need to put the type, which is a float, and then right side arrow to close it in, and we still get this little error right here, and all we need to do is just type in pretty much health max, and then we can say this equals the maximum value, which is 1000.f with the semicolon at the end of it. So now we know this range, it's from 0 to 1000. By default, it's automatically 1000. We can change that at any time. You'll see. So we have health max, and we're just going to go ahead and add another parameter, schematic, colon, range, enter. And then we're going to do one for stamina. Stamina we're going to make a lot larger. We're going to say 3000. So, and then 0, comma, 3000, comma, float, bracket, and then we're going to say stamina max equals 3000.f, and that's it for that. So we're going to hit enter, enter. So basically we have our 2 parameters that we just need right there, and that is, as you can see, we just needed the health max, stamina max, and we're using the schematic namespace for range, which allows us within the editor to have that nice toolbar that allows us to scrub left and right to fine tune what health would be maximum or what stamina would be maximum. Above these two parameters, actually, we're going to add something too, and it's just going to be a simple inline bool, because we need to come back with an operator, and our operator, if I can spell it right, operator, we're going to say equals, and it's going to be constant, and the constant, we're going to call it the same as our constant status, status, versus our strut. Shift 7, which is the ampersand sign, I believe, ampersand, and we say RH constant return 0 is equals memcmp, versus this one right here. And that's going to equal, it's going to equal this, comma, RHS. So shift 7 for that symbol, RHS, which already knows that's what we want, comma, size of, and then another 2 brackets, RHS. And then we can put the semicolon right here. So this is just an operator function for our status. And we need this. So we're going to copy this and just paste it again below. And we're going to change this to and symbols to not equal. So just bang or exclamation point, then the equal sign. And I'm using a certain layout which just gives me this / equal, which means not equal to. Again, that's just for me. Your Visual Studios, you should see an actual sign. You should see exclamation point then equal. But for me, I see this because I'm using something that someone posted. So I'm going to do the same thing for this return, because we need to make sure, since this is not equal to, this would not equal to on return. And that's it for the 2 operators. I won't get too much why we need that, but we do need that. We can just have one, but we're going to use both of these operators. So now the next thing we're going to do now is do our static void reflected type. So static void. Now it's cool that we have these 2 things in our strut, right? We have our health max, stamina max. But to expose this properly, we need to have our reflect type. So our reflect type, and it's just reflect type. And within that parameters, we need schematic, right? The namespace, colon, and it's going to be a C type definition. So C type description, or I think it's description. And then for the description, it needs to take in a parameter. So if I do left arrow, you see right now it says type name type, and then type name enabled equals void. Confusing, you might not know what that means, but what it means, you have to put a class or strut. You have to put something in here, and the thing we need to put is our S status, our strut. So S status, and then right arrow, Shift 8 description, and then enter 2 curly brackets. So this is our reflect type. It takes the status, and now what we can do with this description, description from type description, we can actually start editing what the component, what this specific strut is, what it does it say within the editor, and you'll see. So we'll type in DESC, which is the same up here, and then just hit dot. And the reason why we're not using the pointer is because of this symbol here. We're not pointing into memory, we're grabbing from memory. So with this, we use dot. If this was not there and it was like pointer symbol, which is the star you usually see in C++, then we use a pointer, but we're not pointing, and you wouldn't use a pointer here anyways. So with description, again, dot, we get exposed to all this stuff here. So first thing we need to do is set some stuff. So we're going to set our GUID. And our GUID takes a parameter, which you'll see right here. It says constant cry GUID and GUID, which is a deconstructor. So all that means is 2 quotes for the GUID. And then at the end of the 2 quotes, you just want to do underscore cry, and automatically already knows what I want. Underscore cry underscore GUID. So this. Then at the end, semicolon. So you're probably wondering, how do I get my GUID? And it gives you an example. So this is an example of what it needs to be inside this parameter. Right? So it's a GUID string literal. So what we need to do is go up to tools up here. Go to create GUID. You want to make sure you're on number 4. And just hit new a couple times. I do that because sometimes it'll just show up with your last one that you have. So 4, new, copy, exit. Now within the 2 quotations, we're going to do Control V, which pastes our GUID inside here. And technically now this is ready to be exposed to the editor, this strut right here, but we're going to add some more stuff to it. So the other thing we're going to do is type in description dot set label, and this label is going to say is status params, semicolon, and I'm going to give it a description. So set description, and again it's a constant character, so 2 quotes, and we're just going to say this description sets the default values of status to this entity. Right, simple. You can put any description you want. Matter of fact, you don't even need these 2 if you don't want to put those 2, but I do that. And then now we can add our members. So description dot add, not base but member. So member, again, you can see this long helper here. Don't be scared by it. It's pretty simple. What it needs is a deconstructor of our class or strut or what we're passing through. So what we're passing through is the S status. So fairly easy. You're just going to use the shift 7, which is the ampersand symbol. And I swear, I think I'm saying it wrong. So, in any case, shift 7, which gives you that symbol, and then SSTA, and then for our status. Then we're going to do colon, because we're going to look within our strut to see what we can expose. Not our operators, but we're going to do max health, comma, and now it needs a unique 32 ID. Now you might be thinking this, but that's not what it's looking for actually. Just a single quote. I'm going to give it a special name. Try not to reuse these names for the unique identifier. So we're just going to say heal, right? Simple. And then comma. Now regular quotes, not single quotes. So double quotes. We're going to say health, all one word, max. And then comma. Type it again, health, space this time, max. Then comma. Now we give it a description. We don't need to give it a description if we don't want to, but you can. So we can say set this entities maximum health. Then once we set our description, comma one more time, and now we just give it a default value. So we already gave it a value here. So we're just going to retype that value. So 1000.f, and then at the end, semicolon, and that's it. And we're going to do it one more time for the stamina. So same process, just for stamina. So I'm just going to go ahead and type this out. Just follow along. So shift 7, SS status, colon, and we're looking for down arrow, stamina max, comma, and I'm just going to put stam for stamina. Then double quotes, and let me just zoom in so you guys can see that. And again, stamina max, one word, comma, stamina max. This is with the space now, comma, sets this entity's maximum stamina. Once we're done with that, comma, and our default value is 3000.f. Then at the end of the bracket, just semicolon, right? And that's it. So we can save, and now we can move on to our next part. So our strut's finished. We finish at line 28. And I'm just going to go through this one more time so you can see. And again, anytime you can pause the video. I'm just scrolling left and right pretty slow, so you can pause it where you need it. So the next thing is next. We're going to do protected. So just type in protected with a colon, and it'll automatically shift it to the far left. Hit enter. And what we need is, since we're using the iEntity component, we need some things from this interface. Now, if you don't know what you need, since we are using a template, we can just go to the player.h file right here, and we can scroll down, and you can see right up here. I mean, they put it under public, that's fine, but this is what we need: the iEntity component, the initializer, the get event mask, and process event. And we do need another reflect type, so we're just going to grab everything from line 24 to 35, Control C, go back to our status, and then inside protected, Control V. And the one thing we're going to do is right after this entity component, we're going to type public, give it some space, and then let me just give it some space up here. So inside public, we're going to now write our constructor and our deconstructor. So our constructor is super simple. If you don't know what it is, it's your class name. So this class, just type in the class name. So C status, and you're looking for our class name. Enter. Left and right. Not curly bracket, but curved bracket, if you want to call it. Equals default. And then we're going to do a tilde key symbol. So this operator, this tilde key means deconstructor. And again, we're just going to type CS status. Now for my version of Visual Studios, if I highlight and hit enter, it would actually erase this tilde key symbol, the deconstructor symbol. I know with the version 2019 above, it doesn't do that anymore. Like once you hit tilde key and type and then highlight the class name, hit enter, it will just autofill without erasing the tilde key symbol. Mine does that. Yours might do that. So if you're doing 2017, just don't hit enter like this, because there it goes. It just, you know, deleted the deconstructor symbol, which is tilde key. So that's shift tilde, which is that symbol. It's the key to the left of number 1. And then we're going to, once again, we're just going to do shift 90, which gives you those two, equals defaults. So we have our constructor, deconstructor equals defaults, and we're just going to put virtual in front of this. Enter. Okay, so that's better. So now we have our status with its parameters. We have our iEntity component initial interface stuff that we need. So we can make our component, which is initialize, get event mask, process event. Those are the 3 basic ones you need. There's more that you can utilize, but these are the 3 we're just going to use for right now. And then now we have our reflect type, and it's already giving us an error. It's because it's looking for the C player component. Again, to fix this, just type C status component. Just put status component. We do need to change this GUID. So once again, tools, create GUID, hit new, copy, close, and then highlight from curly bracket to curly bracket, Control V, and there we go. So now we have our unique identifier for this status component. Now with that done, what we're also going to do now is combine our strut with our base component. So we can build like a number of struts and enums that are just like certain parameters that we might want to be exposed, that we will be exposing to the editor, and we can do that above our reflect type for our base class, and then just start adding them in there, and you'll see what I mean. So this is like the basic setup. So we have our strut, so our S status, which has some 2 parameters, just health max, stamina max, and now we're just going to add it to our actual base class component, which is the C status component. To do that, we're just going to give some space here, and then below it, right here, we're going to type protected. Actually, we're going to keep this in public, so we'll keep protected there. Just go above it. And what we're just going to do is simply type SS status, and then we're going to call this M for member, and we're going to say status params, semicolon. That's simple. So SS status params. So this inherits whatever this is. So it allows us to do this. We're going to do description, add member, and the member we're going to add, again, shift 7 for the ampersand symbol, and we're not going to type strut this time for our strut, but we're doing it for our class here. So C S status components : M underscore, and we call that status params, comma, I'm going to say stat, comma, status params, that's fine, comma, status params, comma, give it a description, basic params, that's fine, comma. Now there's one thing, default value. So for this, actually, we can get rid of this there, that description. We're just going to type in no pointer, comma. Now we're going to say SS status. So once you type SS status, shift 90, and then semicolon. So we're not going to have any description. We're just going to say no pointer there, and then SS status. This right here just calls our strut to initialize everything in it. So it's going to just bam, initialize our strut within our reflect type for our C status component. And that's it. So with this, we can hit save, right? Save. And now we're going to set up our CPP file. So we can just test out and make sure everything's working. So first things first, if you just highlight, you see we have a green squiggly line right here. Green squiggly line. Put your mouse over it, you're going to get this icon, this like light bulb. Left click, create definition, and it automatically does this for you. Once it does this, what I do is I go ahead, you can hit Control Alt Home, or you can just hit this button right next to the X, and it just brings it up here to your toolbar. So going back to status component.h, we're going to do the same thing for get event mask, create definition. Now we can just hit close, and then process event, highlights, create definition, exit. And then inside public, or actually under protected, we're going to say void check status. Yeah, check status is fine. Or actually status updates. And then we're going to put floats frame time, because that's what we're going to So now that you type this out, you're probably wondering, especially reading to C++, what the heck is a void, and why do we put float within our brackets here? So void, all it means is that this function doesn't return anything. It's just a straight function. So when it's called, it'll just execute and be done. And then right now, this is called an argument. This is our first argument. If I do a comma, then I can add a second argument, and comma, and so on and so forth. But for right now, we just want one argument, which takes in a float, right? So float, which is frame time. And again, you can name this Billy Bob, doesn't matter. Obviously, you want to name it something relevant to what it takes in. So when you type in that function later and you see frame time as a parameter, you automatically know, oh, yeah, frame time. So we got this green squiggly. Once again, we're just going to create definition, and we're going to hit exit. So we have all that base down. And the next thing we're going to do now is go to save, obviously, and go to our CPP. And we're going to start working on our CPP. So for our CPP file, we're just going to make sure we already have the include for our header. We're just going to, right here, we're just going to hit enter, enter. And then on the top, we're going to say hashtag include quotations standard AFX. The first one on the list. The first one on the list represents this standard AFX. So we have initialize, which means that, hey, this will be initialized first. So anything in this block would be initialized. And then we have get event mask, which just means what event you want from the game system or from the engine, which means like update, did become local, did entity update, all these things that you can grab. So what we're going to do is for this return is get rid of this right here, and we're just going to type in EE entity events, and it's right there. So you can use this namespace. I don't know if they're going to get rid of it per se, but just in case, I'm just showing you that you can use this. So it's EE and entity event, and then colon updates, and then semicolon. There it is. EE entity event update. The other way to do it, I think the proper way to do it, or I don't think, the proper way to do it would be cry for the namespace, colon, E entity, colon, E event, colon, updates. It's a lot more. It's a mouthful doing it this way. So cry entity event update. Don't forget the colons in between. So what that just lets us know is that we're actively looking at the updates. This is what we want. So for the constant this process event, all we need to do is create a switch here. So to create a switch, we can just type again. We're creating a switch, so switch 90, right? So these two brackets, and in here we need to put in a parameter, right? And parameters that are inside of a switch are usually int or bit mask, so that just means it goes 0 to 1. Like it has to be, and I just got a brain fart. But just understand you can't put a float within the switch parameter. It won't take it. You just get an error. So for our events, we're taking this parameter here, this event here. So all we need to do is type in event dot, and then we have these 4 things that we can grab: event, fparam, nparam, and vec. What we want is just event. So event dot event, enter curly bracket, and now we're just going to type case. So for case, cry colon entity colon event colon update. Now this is important. Right after update, you want to make sure you add colon, enter. Now I do this. I do curly brackets, enter, and then right between these two curly brackets. So basically when this is finished, I type break. Make sure you put break. Oops, break. You can do it this way. Break. And just type your code here. Just make sure, kind of put break there, and then you can type your code. That's fine. Break can be right here. You can type your code. That's fine. It's just easier to know that this, within this case function with these curly brackets, it stops afterwards, and that's it. I do it this way. I just showed you another way you can do it. So if you do see it without the curly brackets, don't freak out that they did it wrong. That's another way of doing it. So for my case, inside updates, we're going to call our status, the status update. So the thing we need to do is actually grab a parameter from this event, this sentity event. And to give you a hint, if you just highlight your mouse over update, it automatically tells you too. This is an enum for update, sent when the entity is updating every frame. N param with this right here. So this n param 0 equals pointer to sEntity update context structure, which is what we do not need. But this f param 0 equals frame time, which is what we need. So since we know that from the helper, we can say constant float frame time equals event dot f param, and don't forget the two brackets, 0. So just like that. So this f param 0. So once again, highlight your mouse over this update here, and you'll see the 3 helpers. So f param, this right here, equals frame time. So this frame time will now equal the actual frame. So 30 frames per second, 30 frames, bam, 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 bam. If your computer's a toaster, then it only runs at 2 frames. Well, then every 2 frames, you know, you get the gist. So with that, now we can do, I believe, what I call that, status update. So now we just type in status, and it already knows updates, which takes in a parameter. See, it already knows, hey, status update takes a parameter frame time. Would you look at that? Frame time. Semicolon. Done. So with this, we can hit save. Now there's one more step, right? So above the initializer. So we see that we have everything we need to pretty much get our component working. And technically it can work right now without what we're about to do next. Because if I hit save, build XCOM, succeed, right? Succeed. There's no errors. I can run the game and everything is still good. But we want to expose, like I said, we want to expose this to the editor so we can do fine tweaking within the editor, so we don't have to keep going back and changing things that are hard coded. So if we go to player.cpp, this is the way that they do it in the template. Namespace, static void, they register it, and then they use this macro. This purple right here, this is a macro. If you see anything purple, it's a macro. And to use this 2 macros and for this to work properly, there's 2 includes you need. You need core static instance and environment component.h. These 2. So what we're going to do is copy these 2 includes, delete it from the player CPP, and we're actually going to go to standard AFX and add it down here. So in standard AFX, we just added these 2 includes. Now if we go back to player CPP, everything works. And actually we can grab all this and copy it. And now we can go to our status component. And since we already included standard AFX, we can just paste that here. And we're going to get this error. And again, we just have to change some things around. So for static void, register player component. We're not registering player component. We're registering status component. So make sure we name this register status component, copy it, and then right after the symbol, paste it here. So this can stop yelling at us. And then for the schematic make environment component, we're obviously not using the player component, we're using our C status component. And that's it. Save, build. And if you're using a newer version of Visual Studio's, Control B is to automatically build. My version, I have to actually go here and hit build. Sad face. So we have process events. Everything's looking good. And for the status update, we're actually going to put something to show up on the log. Now don't do this, what I'm about to do. Like, you shouldn't do this as a final build. For testing purposes, definitely, just to make sure everything, you can see things working. But you never really ever want to do this. And again, we're just doing this for testing so we can make sure everything's working. And you'll see what I'm talking about. So we're going to type crylog. And crylog takes a constant character, so that's 2 quotes. And I'm going to say health. Right? So health max, colon. And then right after the colon, we're just going to do the % symbol. And if I can find it on my keyboard, there we go. Dot to F, comma, and now we're going to say M status params dot max health, and then we're going to do, right, so we have max health, and then we're going to do cry log stamina max, same thing, so just shift 5 dot to F, comma, M status params dot stamina max. And it's just this is gonna spam the log every frame what this is. So again, knowing that it's gonna spam the log, obviously that's very inefficient, don't do that, but we're just doing this to test it out. So save everything, build one more time. Great, succeed. So now we're gonna go down to our solutions. You see that game launcher is highlighted. That means once we hit local window debugger, it will automatically launch the game launcher. So what we actually want to do is go to editor, right click on it, set as startup project. Now once we click the local Windows debugger, it actually launches the editor for us, which is excellent. It's obviously this is really good because now we can debug as we're using the editor. So if something happens, like a crash or whatever, it'll actually, you'll see it within the debugger first before it crashes, so you know what happened. So let's go ahead and open up the example level. So our example level is open, everything's looking good. And since we booted up the first time, it loaded in pretty quickly. That's why I wanted it to do that, load in first and then do this, because now doing this process is a lot faster. So if we create object, we're going to go to components. If we go to game, we see spawn point. When we go to general, we're going to see our C status component right there. If we drag that in, see that? It's spamming automatically in the log. And we can see right here what's going on. Right now it's telling us 0. We'll fix that. I know I just remember why it's saying that. But believe me, this is working. You see we have our health max, and we can left click and hold and kind of drag left and right what values we want. And we can do the same thing for stamina. So that way, let me go ahead and let's go ahead and save and close the editor and get rid of these two here. Save again, and let's just go build. And launch one more time so we can go back into the editor. Okay, so opening up the example level one more time. So see, now it's not spamming the log anymore. But you see now we have this ability to like actually affect what the health maximum is and stamina max. And we don't need to like hard code that in. So we can just actually just have this parameter here. You know, we can say So this is spawn point. Let's go ahead and go to components, general, see player component. So there's the player, right? We can add a component. We can go to see status component, and now this component here has a status param, and we can tell it, okay, this particular guy can have 200 health only. That's his maximum, and maybe his stamina is only 100 or 50, or let's say 50. Now you're probably wondering, well, why did you make the maximum 3,000 and the maximum more than 200 if you're only going to use those values? The reason why is because, let's say your game logic has it, like, let's say you're making an RPG, and in the RPG your character is going to really, he might start at a low health, but over time he's going to progress to higher and higher health. Well, if you set a higher arbitrary health number, like 6,000, automatically in your mind that's the point of like absolute maximum that they can reach. So you can start the character at very low health. So we can start our base characters, right? And since we're making a kind of like an XCOM game, we can make our soldiers start with 100 health, and as they experience and level up, they gain extra health depending on what you pour your skill points. We'll probably use something like skill points in later tutorials. So we can say you can pour these skill points into that to increase the health by 50 or by 100 or by 150, whatever. So now we have that ability to scale horizontally. So we're scaling up really well, since we didn't just hard code a small level for maximum health, or just saying maximum health is just 100. Instead, we're saying maximum health is 6,000, and you can be with any point in that range. You get what I'm saying? I hope that makes sense. So let's go ahead and save everything here. Actually, we can delete that guy out of there, and we can delete our entity here. We don't need this two anymore. Oops, cancel, save, and close that out. Let me just look at the time. Okay, time looks good. Alright, so we're going to stop here. This is simple introduction, like I said. I hope this video helped you kind of understand how to set up your first component, right? And just to go over what we did, we created our project. We set up our project and everything like that, naming it XCOM or whatever name that you wanted to use. We created our folders. We put files into proper folders so it looks better within Visual Studios. And then we created two new files, status component.cpp, status component.h, and then we created weapons base component, weapon base component.h. So in the next tutorial, what I'm going to do is elaborate more on the status component. Alright, so all we did is just expose it to the editor, allow us to manipulate the numbers so we can see how we can use that within our game, especially in the game loop, in our game logic. So what we're going to do is kind of expand a little bit more on status on the next tutorial. Pretty much what that means is that we're going to assign the entity this component through code. We don't even have to do it through the editor. We can actually just do it through code, assign it through code, set what we want through code, and then in the editor manipulate it when we want to, if we want to. But we can just do it through code. So that's on the next tutorial. So we're gonna again build upon the status component, assign to our player entity, or actually scratch that. We're not gonna assign it to a player entity. We're gonna build upon status component. Once we do that and check to see it all works, then we're going to actually break apart the player component. And what I mean by that, the player component, the way that the game is built, right? So if we actually go to Game Launcher and set this up as Starter Project Game Launcher, and we launch. Right now, this is the template. Wherever I click, he goes, and if I hit spacebar, he shoots. We don't want that at all, right? What we want is to make kind of like a grid on the floor and point to him where he needs to go, and he'll follow that grid, kind of like on XCOM movement speed. Or, depending on what you guys say in the comments, we can keep this style of play and just use stamina. So let's say from here to here is 20 feet, and for a certain amount of distance, his stamina is decreasing per second or whatever. So if he only has little stamina, he only can go like maybe this far and that's it, and he stops automatically. Which way, we'll figure that out, and we'll just code it in, and then we'll just build a cover system. So to do that, we need to actually rip out the most of the stuff from player and give it to like an actor system, and then we'll apply that to all our AI that we're going to be moving around the world with. And the player is just a camera system that will just be able to click on his soldier or whoever, and then tell him to move if that's the one he has selected. And then we're going to go over from selecting our allied soldiers, and then we can also probably introduce a drag and drop. So left click and hold it to make the drag and drop. I'm saying drag and drop, and I know that's the wrong method. Do it like this pretty much. So we can left click and hold and highlight over as much as the people we want to move them. So with that in mind, I hope you guys enjoyed this tutorial. I hope it really gave you an insight on the basics. And with that in mind, I'm just going to go ahead and end the video, and hopefully sooner than this video came out, I'll have the next video out. And like I said, for the next video, we're just going to elaborate on the status component, add some more stuff to it, and then from there we're going to take apart the player component, and then change the camera, or keep the camera the same and change some things, and then create our actor class. And then once we create our actor class, start working on simple game loops and game logic from there. Alright, so thank you for watching, and hope to see you in the next video.